One example of dynamics of circular motion occurs when an automobile rounds in a highway curve. In such cases, maaring maramdaman nung passenger na nasa loob ng vehicle or ng automobile ang tinatawag natin na outward force or yung force na itinutulak siya sa kanyang right direction. So for example, in an unbanked highway curve, in this figure, yung ganong situation is because yung passenger na nakasakay dito sa part na to, ang path ng motion ng passenger is straight line. Whereas yung vehicle naman has begun to follow a curved path. Ito, yung highway curve na kanyang dinadaanan. And habang nasa circular motion yung vehicle na sinasakyan ng passenger, merong dalawang force na nag-a-act dun sa passenger. The automobile seat and the door exerts a force on the passenger. So, yung ibinibigay na force ng seat is yung friction na mararamdaman habang nakaupo. Pangalawa is yung force na ibinibigay ng door, yung tinatawag natin as the contact force, a direct contact force. And also, para makamove yung vehicle in a curved path, the vehicle also must have a force exerted on it toward the center of the curve. Meron siyang force na ibinibigay pa ganyan. On a flat road or on an unbanked road, this force is supplied by friction between the tires and the pavement. If the automobile's wheels and tires are rolling without slipping or sliding, the friction force the road exerts on the tires is a static friction or a static frictional force. And that's because yung bottom of the tire, yung ilalim ng tire ay nakarest against the road at the instant na nagro-roll siya. And that means that mas malaki yung frictional force static dun sa centripetal force na nararamdaman ng vehicle. Kung yung static friction na to ay mas maliit kesa sa centripetal force, like for example, madulas yung road or sobrang bilis ng vehicle, yung static friction is less than the centripetal force, yung vehicle ngayon ay magsa-start na mag-skid, yung tinatawag natin na skidding, out of a circular path into a more nearly straight path. Hindi na siya susundan, and yan yung nagiging causes ng accident. And once na yung vehicle ay mag-skid or mag-slide, the friction force becomes kinetic friction, which is smaller than the static friction. Take note that when the tires are rolling, nag-e-exist yung static friction. Pero pag nag-stop na siya sa pag-roll, magkakaroon na lang ng sliding yung tires, and the friction force, which is now kinetic friction, ay mas mababa na. More importantly, yung direction ng friction force ay nagbabago suddenly kapag nag-stop na yung wheel. Static friction can point perpendicular to the velocity. Kaya lang kapag nag-slide or nag-skid ng vehicle, yung kinetic friction points opposite to the velocity. The force no longer points toward the center of the circular motion, and yung vehicle cannot continue in a curved path. And in such calculations, kapag mas maliit na yung static friction kesa sa centripetal force, dito na pumapasok yung bank highway curves. So the banking of curves can reduce the chance of skidding. Nalilesen niya yung pag-skid or pag-slide ng vehicle. One example of bank curves is yung sa car racing, and makikita natin in this figure, the normal force exerted by a bank road, yung normal force na nararamdaman ng vehicle, is acting perpendicular to the road. Always, again, as we have discussed in the dynamics chapter, yung normal force ay laging perpendicular dun sa surface. So for example, this is the bank surface, and ito yung car. Yung normal force is perpendicular, and again, yung kanyang weight is always downward. Say, we have an angle here, tinatawag natin as the banking angle. Itong normal force ito ay magkakaroon ng components papunta dun sa center ng circular motion. So we have here normal force X, and this is normal force Y. These bank curves are reducing the reliance on friction. For a given banking angle, there will be one speed for which no friction at all is required. Ito yung mga case when the horizontal component of the normal force toward the center of the curve, say itong Fnx, or kapag sinulat natin yan, ito yung angle natin, andito siya. So Fnx is equal to Fn sine theta. And yung normal force at sine theta na yan is just equal to the force required to give a vehicle the centripetal acceleration. That is when yung centripetal force natin, the centripetal force is equal to Fn x, or yung Fnx na yan as the Fn sine theta. Ang formula natin for centripetal force is equal to mv square over r. So, magiging equal sila, and we have the equation Fn sine theta is equal to mass times the velocity square over r, or the normal force at the x component is simply equal to the centripetal force. So this is the equation for our F sine theta. And for Fn cosine theta naman, pwede natin siyang equate. Ito siya. Equivalent niya yung weight ng vehicle. And yung weight ng vehicle is simply equal to mass times gravity. Now, if we divide the F sub x, or normal force sub x, by normal force sub y, say Fn sine theta over Fn cosine theta, so this is equal to mass times velocity square over r divided by mass times gravity. Pwede na nating makancel yung normal force. In case walang given sa atin na normal force, pwede rin natin makancel yung mass in case na walang given na mass. Sin theta over cosine theta is equal to tangent theta. So tangent theta is now equal to v square over gravity times the radius, or simply in this derived formula. The banking angle of a highway curve, say theta, is chosen so that yung condition holds for a particular speed, yung tinatawag natin as the design speed. So as we can see in this derived formula, yung proper banking angle depends only on the velocity and on the radius. Hindi nakadepende dun sa mass ng vehicle. If a vehicle goes around a bank turn more slowly than at the design velocity or the design speed, the friction tends to keep it from sliding down the inclined roadway. And if the vehicle naman goes faster, mas mabilis, the friction tends to keep it from skidding outward. If the vehicle speed is too great, however, yung friction may not be sufficient to keep the car on the road, and yun yung mga nagkakos ng accident. Example number 1, a vehicle is traveling at 20 miles per hour on an unbanked road where the coefficient of static friction between tires and the road is 0.8. Find the minimum turning radius of the car. So let's draw the figure. So this is the unbanked road and this is the car. Merong weight dito. Draw natin yung forces, or pwede rin free body diagram. And merong normal force dito na perpendicular sa surface. And habang nagtatravel siya papaganito, meron siyang nararamdaman na centripetal force or yung FC, and yung frictional force dito na paganito. To solve for the minimum turning radius, ang formula for the centripetal force is equal to mv square over r. So nandito yung radius, and to solve for the centripetal force, using the figure, centripetal force is equal to, eto lang yung force na kapareho niyang nasa isang component or nasa x component. So this is equal sa force of friction. So centripetal force is equal to mass times the velocity square over r, and yung frictional force naman natin is equal sa coefficient of friction or coefficient of static friction times the normal force. Kaya lang, yung normal force naman by y component, normal force is simply equal sa weight or sa mass times gravity. Mass times velocity square over r is equal to the coefficient of static friction times mass times gravity. We can now solve for the radius. So we cross multiply. R is equal to mv square over coefficient of static friction times mass times gravity. Pwede na natin i-cancel yung mass. radius is equal to v square over the coefficient of static friction times the gravity. Pwede na natin i-direct substitute yung given values. Kaya lang, we need to convert the velocity first in 20 miles per hour into feet per second. And ang gagamitin na natin na gravity is, in English, 32 feet per second square. So, ang velocity natin at 20 miles per hour is equal to 29.4 feet per second. Ito na yung gagamitin natin na value for the velocity. 29.4 feet per second quantity square over the coefficient of static friction is 0.8 times the gravity na 32 feet per second square. By calculating, ang value ng radius is equal to 34 feet. This is the minimum turning radius nung circular motion, and this is example number 1. Example number 2, calculate the maximum speed with which a 1,500 kg vehicle can make a turn around the curve of radius 20 meters on a level road without sliding. The coefficient of static friction is equal to 1. So, let's draw again the figure. Same lang sila na figure ng example number 1. The only force in the x direction toward the center of the circle is the static friction. Ito. And yung frictional force na yan, or static frictional force, is equal to the centripetal force. Dalawa lang naman sila sa x component. So, frictional force is equal to the centripetal force. Frictional force is equal to coefficient of static friction times the normal force equals mass times velocity square over r. Ito yung centripetal force. And again, sa y component natin, itong Fn na to, since dalawa lang naman na nag-a-act, we have normal force and we have the weight. Normal force is directly equal to weight, which is directly equal sa mass times gravity. Coefficient of static friction times mass times gravity is equal to mass times v square over r. And pwede na ulit natin i-cancel yung mass. Because the static frictional force has a maximum value, there will be a maximum speed at which a vehicle can turn without sliding. So, yung speed na yun is reached when the static frictional force reaches its maximum value. Say for example, Fs max, or ito yung static frictional force maximum, equals coefficient of static friction times mass times gravity. If the vehicle enters the curve at a speed higher than the maximum, yung static friction cannot provide the necessary centripetal acceleration and magsaslide na yung vehicle. Thus, the maximum speed occurs at the maximum value of the static frictional force, or when itong static frictional force maximum is equal to mass times maximum velocity, or Vmax square over r. So, kung dito na natin i-equate, eto, we have coefficient of static friction na nakancel na natin yung mass times gravity na lang ito equals ito Vmax square over r. Let's derive the equation. Cross multiply. Vmax square equals coefficient of static friction times the gravity times the radius. And square root ng magkabilang side of the equation to cancel the square. Vmax, or the maximum velocity, is equal to the square root of coefficient of static friction is equal to 1 times the gravity na 9.81 meters per second square times the radius na 20 meters. By calculating, a maximum velocity is equal to 14.01 meters per second. So this maximum velocity na 14 meters per second, which seems like a reasonable upper limit for the speed at which a vehicle can go around the curve without sliding. So this is example number 2. Example number 3, a curve on a racetrack of radius 70 meters is banked at a 15 degrees angle. At what speed can a car take this curve without assistance from friction? Let's draw first the figure. So this is the bank road with a 15 degrees angle, say theta. And this is the car. The car has a weight na pababa lang. And yung normal force na perpendicular sa surface. So, normal force na yan, kailangan nating ilagay yung components. We have two components, F and X, and the F and Y. So, take note, itong angle na to is equal sa angle dito. 15 degrees din. According to the problem, we have no friction here. So, without the friction, this is the only component of force toward the center of the circle. And ito, at X component, Fn x or the Fn sine theta is equal to the centripetal force na mass times velocity square over r. Since yung ating centripetal force is in this side, Fc, and sa y component naman, Fny is equal to the weight, and yung Fny na yan is Fn cosine theta equals yung weight is mass times gravity. So, we will use these two equations to solve for the speed. Kagaya ng ginawa natin dun sa explanation natin kanina sa bank curve, when we divide this equation by this equation, we will obtain tangent theta equals v square over gravity times radius. And using this equation, dito na natin masasolve yung velocity. So, we cross multiply. Velocity square is equal to gravity times radius tangent theta. Square na magkabilang side. Velocity is equal to the square root of 9.81 meters per second square times the radius na 70 meters times tangent theta na 15 degrees. And by calculating, velocity is equal to 13.56 meters per second. Again, this speed is a reasonable speed. Only at this exact speed can the turn be negotiated without reliance on friction forces. So this is example number 3. On a road that is banked at a proper angle, a vehicle rounded the corner without any assistance from friction between the tires and the road. Calculate the proper banking angle for a 900 kg vehicle traveling at 20.5 meters per second in a turn of radius 85 meters. So by drawing the figure again, this is the bank curve with an angle theta, and ito yung vehicle. We have the weight of the vehicle and the normal force na perpendicular sa surface. And yung normal force na yun has two components, F and X and F and Y. So in order for the car to move a circular path, there must be a force acting on it in the positive direction. In this problem, ang hinahanap sa atin is yung proper banking angle naman. And using the derived formula natin dun sa discussion sa bank curve, tangent theta equals v square over g times r. Hindi na natin kailangang i-derive. Directly, gagamitin na natin agad itong formula na ito. To solve for the angle theta, this is equal to inverse tangent or tangent raised to negative 1 times the velocity square. Ang velocity is 20.5 meters per second quantity square over the gravity na 9.81 meters per second square times the radius na 85 meters. So, by this direct substitution sa formula natin na na-derive kanina, ang value ng angle theta is equal to 26.75 degrees. Again, take note that kung hindi natin alam itong direct formula na ito, we can just derive by the principle of free body diagram. We just always have to remember that itong F and X, kapag nasa banking angle at kapag walang friction, directly equal na siya sa centripetal force na merong value na mass times velocity square over r. So this is example number 4.